All right, today we are doing section 512. We are kind of out of chapter 5, but this is the very last section we got to do out of it. We are going to solve quadratic equations by factoring. So we have to use our factoring skills, which is why our warm-up involves factoring expressions. Now, as a quick reminder, when we say we are going to factor something, what does that mean? When we're going to factor something, we are going to write it as a multiplication problem. Somebody remembered. So write as a multiplication problem. Ran out of room. Okay, and what symbols do we usually use to indicate that we are multiplying? Parentheses. So remember, we will use parentheses a lot on these. Now, if you still have your flow chart, that could come in handy today when we are having to factor some of these. The first thing we're supposed to look for is a GCF. On number 1, do we have one? No, so then we ask ourselves, how many terms does it have? How many terms do we have? 3 terms on number 1. 1, 2, 3. Then we ask ourselves, is the leading coefficient equal to 1? What do we think? Yes. So does anybody remember what method we use then? The X method. Very good. When we go to fill in our X, what goes on the top? The 10. Whatever we're multiplying to, the constant from the back goes on top. What about on bottom? The 7, whatever we're trying to add up to. So we need 2 numbers that multiply to 10 and add to 7. Natalie, what are they? 2 and 5. But then that's not my answer because I have not written a multiplication problem yet. Jaquan, how do I write my answer? Very good. X plus 2 in parentheses and X plus 5 in parentheses. That's how we show it as a multiplication problem. All right, on number 2, we go through those same set of questions. What method are we going to end up using here? Good. On number 2, we need the X method again. If you go through that same set of questions that we did on number 1, we got to have the X method. What number's going in the top this time? A negative 15, and in the bottom? A negative 3. Now, if I need to multiply to a negative number, I know my signs have to be 1 negative and 1 positive. So I know I need 2 different signs. So with that in mind, can anybody think of what 2 numbers we need? Jaquan? Negative 5 and what? Right, so our initial thought is something like negative 5 and 3, but that wouldn't give us a negative 3, would it? So that doesn't work. If I switch the signs, is that going to help? If I have a 5 and a negative 3? No, still doesn't work. So what are my other options, Ryan? Prime. So my only other options would be something like negative 15 and 1. Still doesn't work. 1 and negative 15 still doesn't work. So once we've used up all our possible factors and nothing worked out, then we can say that it's prime. Now, I don't think that we'll have any prime ones today. We'll see, but in order to do what we're trying to do today, we can't do it with this method if they're prime. So I don't think we'll see many more prime ones just yet. All right, number 3. Are we using the X method again? I heard somebody say no. Why not? Good. The coefficient in front is not a 1, so we cannot use the X method. We have to use bubble method. Good. All right, so what's my only option for my first bubble? 1 and 2. I guess it's good if we talk about what our signs should be. What are our signs going to be? Careful. 2 negatives. If we are adding in the back, they've got to have the same sign. So the sign in the middle tells us what it's going to be. Both minus. What are we looking for? I think I heard somebody say it. -7. I'm just old and deaf. All right. So we've got a 1 and 2 in our first bubble. What are our options for our second bubble? 1 and 6 or 2 and 3. And of course, we know already that they would both be negative. Any thoughts? -3 on top and -2 on bottom. When I connect my bubbles, what operation am I going to do with those numbers? Multiply. 1 times -3 is -3. 2 times -2 is -4. When I combine those, I get beautiful. So that's what I wanted. Now I'm ready to write my answer. Remember, on these, writing your answer can be a little bit tricky. So we go ahead and set up our parentheses. I like to fill in the front part of both parentheses first. Who can raise their hand and tell me what should go in there? Just in the front of both of them. We're going to need some new hands. Deshaun. Just a 1 and a 2? What should go with the 1 and the 2? Oh, P. Sorry. Remember the old and deaf part? All right. Now I have to fill in the back part of my parentheses. Deshaun, you want to finish it off? Good. A -2 in the front. And then a -3 in the back, because when we make our little smiley faces, the same thing should be connected that were connected in the bubbles. So 1 connects to -3, 1p connects to the -3, 2 connects to -2, so the 2p connects to the -2. Questions? We all remember how to factor? If you want to have out your factor sheet or your flowchart sheet today, that might help. All right, this chapter we are studying quadratics. It says yesterday, when it wasn't really yesterday, it was last week. We looked at how the quadratics looked on the graph. Their shape is a parabola. Now, that word might not mean a whole lot to some of us, so what did those graphs look like last week? A U. So if you want to draw a little U next to the word parabola, or an upside down U, little arch next to it. Today we will be solving a quadratic equation. The solutions will represent the x-intercepts, or where the graph crosses the x-axis. For what we're doing today, we need to use the zero product property. It says for all real numbers a and b, A times B equals 0. So you need to write that down. A times B equals 0. If and only if A is not equal to 0. That's if and only if A is equal to 0 or B is equal to 0. And now on these first couple problems, go ahead and write them down. Examples 1 and 2. What's nice about these first couple problems is that they already did the factoring for us. So we already have a multiplication problem that is set equal to 0. All right, these are already factored for us. So the previous slide said if you are multiplying two things together, which we're doing here, we've got two sets of parentheses multiplied together, and it equals 0, then you could set each one of those factors equal to 0. So either x plus 2 is going to equal 0, or x plus 5 is going to equal 0. That's how we're going to treat these problems. Once it's factored and set equal to 0, each factor, which usually means each set of parentheses, gets set equal to 0. What do you think we're going to do to both of those equations? It's already been factored. If I were to give you something that looked like this that I just boxed in on a test, what do you think I'm wanting you to do? Why would I subtract 2 from both sides? To figure out what x is. That's what I want you to do here. I want you to get x alone on both of them. So Jaquan said on this one we would have to subtract 2 on both sides. 0 minus 2 gives me -2. So that's part of my answer, but I still have another equation to solve. Jakeem, how am I going to solve that second equation? Good. Subtract 5 from both sides. 0 minus 5 is -5. Those are my two answers. When we are solving quadratics by factoring, we will usually have two answers. There are some special situations where you get the same answer 2 times instead of getting 2 different numbers, but usually it'll be 2 different numbers. Moving on to number 2. Again, they already factored it for us, so we need to set up our equations. I think it's about time we go to the sticks. The time has come. Kion, can you tell me one equation that I should set up?
Is that 1?
Yep.
We're on number 1 or 2?
We're on number 2.
You said that's 1.
Yep.
X plus 8.
X plus 8 equals
0.
0. That's going to be one of the equations that I'm going to have to solve. Jeriel, what do you think the other equation is? So we use those parentheses up. Good. The other one would be 3x minus 1 equals 0. We got to take each factor or each set of parentheses and set it equal to 0. That's how we set up our two equations. Lexi, can you tell me how to solve one of these? Good. On the second one, we would subtract 8 on both sides. And Lexi, what would we get? Beautiful. All right, we still have to solve the other one, which is going to take a couple steps. Jaquan, what should I do to solve 3x minus 1 equals 0? And then do what? Then once we've got 3x equals 1, we divide both sides by 3. X is equal to 1/3. So there are our two answers. All right, get example 3 copied down real quick. So 5n times n minus 3 times n minus 4. Now I'll go ahead and tell you up front, this one did not come from a quadratic. But that doesn't mean we can't do it. On this one, how many different equations do you think we need to set up? 3 of them, because we have 3 factors. 3 equations for all 3 factors. Jalen, can you tell me one equation I need to set up? Equals?
0.
Good. One of them is going to be n minus 4 equals 0. May, what's another one? N minus 3 equals 0 is another one. Jamaro, what's my last equation? So we used up those 2 factors. Which one's left? 5n equals 0. Each factor gets set equal to 0. Even though the 5n was not in parentheses, it's still considered a factor. It's still getting multiplied to everything else. So this time, how many solutions will we end up with? 3 of them. We set up 3 equations. We're going to get 3 solutions. Connie, can you tell me how to solve one of these? Yep, on the middle one we would add 3 to both sides. 0 plus 3 equals 3. Good. All right, on another one. Danielle, how would we solve another one of these? Good. On this last one, we add 4 to both sides. We get that n equals 4. So we're left with that first one. Houston, how would I solve that first equation? 5n equals 0. We divide both sides by 5. 0 divided by 5 is 0. And we got all 3 of our answers. Questions, concerns? So that was when everything was already factored out for us. Moving on. In order to solve quadratic equations by factoring, the equation must be in standard form. So fill in those blanks, standard form. And then also write down what standard form is. Standard form is ax squared plus bx plus c equals 0. So that's really important. I would highlight it, put a box around it, something. We have to be able to know what standard form is for these. It's also super, super, super important that it equals 0. So I'd maybe put an extra star or arrow by that. It's got to be set equal to 0. If it's not equal to 0, we cannot use that 0 product property and things just don't work out. All right, it says solve by factoring. Solve by factoring. Now, the first thing we should check on these is if it is in standard form. Is this in standard form? Yes. We've got the x squared, then the x, then the constant, and it's set equal to 0. So if it's in standard form, we can keep going. After we check for standard form, we are going to factor this. Now, the equals 0 part is just going to stay there. Don't leave it off. You can write that down right away. And then we look at what's left on this other side, and we have to decide how we're going to factor it. What method are we going to use to factor that? The x method, because it's got 3 terms, no GCF, and our leading coefficient is equal to 1. So we use our x method. So we kind of don't use the 0 when we do this. We write down the equals to 0, but it does not have anything to do with how we factor it. Does that make sense? Okay, what number is going in my top? 48. What number is going in the bottom? 16. So I need 2 numbers that multiply to 48, add up to 16. So like I said, it might help if you have your factor sheet out today, since we are going to do a lot of factoring. So once we've got our 12 and our 4, we have to write that as a multiplication problem. And I don't mean 12 times 4, I mean set up our parentheses. Who can tell me what goes in them? Keon? And? Good. X plus 12 and x plus 4 goes in the parentheses. Now, last week, couple weeks ago, that's where we would have stopped. But this time, we've added in that equals 0 part. So we are going to keep on going until we know what x is. So Natalie, can you help me set up my equations?
X plus 12 equals 0, x plus 4 equals 0.
Very good. So each factor gets set equal to 0 on its own, and then we solve them. Deshaun, can you help me solve these? So how would I solve x plus 12 equals 0? Good. Subtract 12 from both sides. So x equals negative 12. And on the other one, what would I do? Subtract 4 on both sides. X equals negative 4. There we go. We got our answers. So that's what we're doing today. We are factoring these and then setting each factor equal to 0 and solving. All right, on example 5, are we in standard form? Let me see a thumbs up, thumbs down. Who thinks we're in standard form? Thumbs up. If you do not, thumbs down. Need to see a few more thumbs. We are in standard form, so we can move on and start factoring this. What method do I use to factor this one? The x method. Taking it easy on us today. What number goes in the top? A positive 1. In the bottom? A negative 2. I need to multiply to positive 1 while adding to negative 2. Both of them are going to be negative 1. So I need to use that to set up my multiplication problem. So remember, that means I'll be in parentheses. I also need to keep the equals 0 part. So whether you write that down right away or you wait till the end, At some point, you got to get that equals 0. You cannot drop it off. So what's going in those parentheses that I set up? Jakeem, what's going in those parentheses? And? Very good. They're both a minus 1s because my minus 1s are on both sides of my x. Now I have to set up equations to solve. Delaney, what are my equations? Oh, you're getting a step ahead of me. I haven't set up my equations yet. All right, so we notice on this one that our equations end up being the same. So remember I told you when we got started on these, usually you'd have two different answers. On this one, it's going to be one where we have the same answer both times. So really you only need to write it once. And Delaney told us when we got started that a equals 1, and that is correct. Now, if you go ahead and solve both of them and you show the work on both of them and you write it down twice, that's fine. But if you get the same exact answer on both of them, it's okay if you only write it down one time. But it's got to be the same exact answer. If they're different, even just by a sign, then they're not exactly the same. Questions, concerns? Ready for another one? All right, let's copy down example 6. Is example 6 in standard form? No. Ooh, we got a debate, yes or no? No, why not? It's not equal to 0. We need it to be equal to 0 if we're going to continue on. So how am I going to force this side to be a 0? Add 13, but if I do that to one side, I have to do it to the other side. Now this is where it's going to get a little bit tricky for some people. Not for all of you, hopefully not for any of you, but I've seen it happen in the past. We are going to have a c squared. Most people get that part right. And then in the past, I've had some students tell me that this would then be 27c. Why does that not work out? Very good. The 13 does not have a c, so this stays plus 14c. And what do we do with that plus 13? Just add it on the end, plus 13. And then it would equal 0. Do we have questions about that step? Okay. Now that it's in standard form, we are ready to factor. What method are we using? X method. What's going on top? And on bottom? What numbers are going to work for us? 1 and 13. We go to put that into our parentheses. Who can tell me what that's going to look like? Deja? C plus 13 times c plus 1. What do I need to remember on the end there? Equals 0. Good. Once we do that, once we're done factoring, we're ready to set up our equations. Any volunteers to tell me what my equations will be? Jaquan? C plus 13 equals 0. C plus 1 equals 0. And then I have to solve both of those. Jamal Dixon?
C equals -13.
Good. C equals -13. And the other one? C equals -1. Got my two answers. We are all done with that problem. Example 7, t squared minus 7t equals 30. Are we in standard form? No, we need this to be set equal to 0. So what am I going to do, Jamal? Subtract 30 from both sides. Now, is there anything for this minus 30 to combine with? No. Sometimes there might be, but in this case there is not. So t squared minus 7t minus 30 equals 0. Once we're set equal to 0, we are ready to begins with an F. Factor. We are going to factor this. All right. We need to factor this. What method are we using? The X method. What's going on the top? Negative 30, and on the bottom? Negative 7. 3 and negative 10. Good. Those would multiply to a negative 30, add up to a negative 7. So we have to rewrite our problem factored. So we need to write this as a multiplication problem. Nevaeh, how would I write my problem now that I know what my numbers are?
T plus 3.
Good?
And
What?
then t minus 10.
Good. And what needs to go on the end there?
0.
Very good. Equals 0. Once we've got it factored, now we can set up our two equations. Here, Jamal Dixon, what are my two equations?
T plus 3 equals 0.
And?
T minus 10 equals 0.
Very good. All right, last step, we got to solve those equations. Tariana, can you help me out with solving?
Subtract 3 on both sides. And add 10 on both sides. Wait, you want to do the other one too?
Yep, so what do we get for t on both of those?
T equals negative 3. And t equals 3.
Very good. T equals negative 3 and t equals positive 10. Questions, concerns? Nothing at all? Ready to continue? Okay. On number 8. Are we in standard form? Yes, we sure are. We've got our x squared, then our x, then our constant, and most importantly, it is set equal to 0. Once we know that it's in standard form, we are ready to factor. How are we going to factor this one? Bubble method. We have to use our bubble method because we have 3 terms, but our leading coefficient is not a 1. So, when we factor with our bubble method, what are our signs going to be here? A negative and a positive. If we are multiplying in the back to a negative, we've got to have different signs. What are we looking for? A positive 5. So we start setting up our bubbles. What has to go in my first bubble? A 1 and 2. What are my options for my second bubble? 1 and 12, 2 and 6, 3 and 4. And we know one of them will be positive, one of them will be negative. Anybody figure out what our second bubble needs to be? Jay Sean? Negative 3 and 4? Negative 3 and a 4. When I connect my bubbles, I have to multiply 1 times negative 3, 2 times 4. When we combine them, beautiful. That's what we wanted. So we know that these bubbles will help us write our factors. So we go set up our parentheses. We know that after our parentheses we'll still have what? Equals 0. I need somebody to help me fill in those parentheses. Can? One x and 2x in the fronts. Where do you want the minus 3 to go? So remember, the 1x connects to the back here, and we want it to connect to the minus 3. So the minus 3's got to go back there, which means the plus 4 goes in the first parentheses. So make sure we're careful about how we set those up. If you don't get this step right, you're not going to get your answers right. And that would kind of stink because you've done all the work right so far. The last couple steps are usually the easiest ones. I need to set up my equations. What are they? Kelby, what are my equations? And? Good. And then we have to solve both of these. To solve the first one, what am I going to do? Subtract 4. X equals -4. On the second one, we've got a couple steps we got to take. What are we going to do? Add 3 and then do what? Divide by 2. Good. So then my answer is x equals what? 3/2. Just leave it alone. If you were to write it as 1.5, I would accept that, but I don't really want it. Just leave it as 3/2. Don't take the chance of messing something up on that step. We are going to stop these notes here, but you need to bring this sheet back with you tomorrow so that we can finish it up.